Well, good morning, rebels, or good afternoon or good evening for those that are getting around to their chem homework. Start of a new unit today. We are starting our bonding unit. So this unit starts with a lot of vocab. We have to show a couple kind of shortcuts. We didn't cover everything on periodic table that we sometimes do, so there's a couple extra things. We didn't get to electron configuration. So I'm going to try and go quickly through the vocab, help you out with electron dot notation, um, and then you should be ready to dominate your assignment. I'm going to warn you when it comes to the bonding unit, everything kind of builds. So if you're not understanding one day, it might catch up to you. So it's important to stay on the meets, ask for help. If you are passive throughout this unit, it's going to be too little too late when you wait until the night before the test to try and teach yourself all of it. If you stay on top of it, this isn't that difficult of a unit, but waiters doesn't go well. Today we're going to talk about ionic bonding, and the whole point of ionic bonding is atoms bond together to form compounds, and when ionic bonding, they either gain or lose. We'll eventually get to sharing electrons, that's covalent, but the important stuff you need to understand are valence electrons. So I'm going to start with that. Valence electrons are the electrons in the outermost energy level. So the other electrons we don't care about. We tend to just care about valence electrons. Why do we care about valence electrons? This is why we had families like the alkali metals, the noble gases, halogens. It's all due to valence electrons. So it's the valence electrons that essentially stick together. So water forms water because of its valence electrons. We're held together by a bunch of elements based on our valence electrons. So this is why atoms stick together, is they're always trying to either gain, lose, or share their valence electrons. So those are really the important stuff. They determine why metals blow up when you put them in water, like the alkali metals, or the noble gases that don't react are all due to their valence electrons. So this is the part I would write down on your periodic table, how to find valence electrons. When we taught electron configuration, I would teach it to you that way, but because we skipped that, I'm just going to go cheat code. All you gamers out there, here's what you really need to know. So this first group, group one, they are always just going to have one valence electron. So I just point this out. If you get a pen out, starts the circle game, this is much easier, where group one, oh, ew, where'd my pen go? Pen. Group one has one valence electron. So hydrogen, lithium, sodium, they always have one valence electron. I know some students write a one down here. Group two valence electrons. So strontium has two valence electrons. Barium has two valence electrons. And then we skip the transition metals. They tend to have two. We'll talk about that when we get more into ions and what that means. And then what I do with this is I just circle, ignore all the ones, and I just circle the three here. See if I'm good. I can cross it out. Boron, aluminum, gallium, they all have three valence electrons, and the pattern continues. So carbon has four, nitrogen has five, oxygen has six. Pretend that looks like a circle. Fluorine, chlorine, bromine, the halogens all have seven, and then noble gases have eight. Now, the one exception to that is helium only has two, but the rest of them all have eight. So the cheat code, I just want you to kind of make sure and try. Look, all of these have one, two, and then if you just circle the last part of the group, you got the rest. 3, 4, 5, 6, 7, 8, like that. So if we just do a real quick practice, I'm hoping if you have your periodic table labeled, this is really, really fast. How many valence electrons do each of those have? Calcium has two valence electrons. And we got fine carbon. Carbon has 4 valence electrons. And then finally, bromine. Bromine has 7. All right, moving along. And then we get to something called electron dot notation. So this is in a PDF. As sooner you get this down, the faster the labs are going to be as we go through this unit. But essentially, this is our shortcut for valence electrons. So we haven't explained what S and P orbitals mean for now. That doesn't matter. The whole idea is they want to get 8. So what the shortcut of this is, if we go back to the examples we just did calcium. We would do the symbol for calcium, and calcium has how many valence electrons? 2. We would do 2 dots, where the 1 and the 2 are. The next one we did was carbon, so carbon would be there, and by what we're giving you today, we would just go 1 dot, 2 dot, 3 dot, 4 dot. There's 4 dots because there's 4 valence electrons. And the last one I have is chlorine. Chlorine had, I think it was chlorine. Oh, just kidding. Bromine. Guess it doesn't matter. We'll go through both. Bromine had 7, so you would go 1, 2, 3, 4, 5, 6, 7. And chlorine, because it's in the same family, they're both halogens, would also have 7. 1, 2, 3, 4, 5, 6, 7. Time for lunch. Just kidding. I'm going to finish this. So electron dots are just a shortcut for going through this. Now, this is very note intensive. It's all on there, but here's your cheat codes for doing today's homework. All atoms want to be like the noble gases. We call this the octet rule. Pretend that's an underline. They want to get 8 valence electrons. You're going to see that a lot. 8 valence electrons, noble gases. They're the king and queens. Everyone wants to be like them, the cool kids. They do this by gaining or losing electrons. So atoms, if they're not a noble gas, will gain or lose electrons to form ions. So one of the questions will be, what's an ion? It's an atom or a group of atoms that are positive or negative. Atoms will gain or lose electrons, and that's how they become ions. This right here is probably the most important. I would write this in your notebook. It's going to answer a ton of questions as we go through here. Metals will always lose electrons. If you get this down, there's no math game. They will become positive. Remember, electrons are negative. And the vocab word of the day is they become cations, not cations, not cations, cations. Nonmetals and metalloids tend to gain. Remember, electrons are negative. So if they gain, they become negative and they become anions. So today's goal is to kind of get you to understand some of this vocab for those that are visual. Cations, I always teach it this way. If you do your T without a little tail, this looks like a plus sign. So cations are always positive. That's because they're losing electrons. So if you need to write something down, ignore my finger. They're losing electrons. Anions are always negative because they are gaining electrons. That's the vocab we kind of got to get down as we go through here. This is all on the PDF. So if you get metals always lose, nonmetals always gain. Friendly reminder where metals and nonmetals are. Those that like math, this does a pretty good job of explaining it. I will go into that more tomorrow as we talk about this. But the whole goal or point of all of this is atoms want to get 8 valence electrons. So they do that by gaining or losing. So that's what we're getting to as we keep going through this week. So I just wanted to end with this, very similar to what your homework assignment will be, that we say, okay, what's the electron dot for potassium? You have to find potassium. Oh, that's K. How many valence electrons does potassium have? 1. So we're going to do a dot right there. And what the ion symbol is this. Is potassium a metal or a nonmetal? Potassium's a metal. That means potassium's going to lose. Well, how many dots does it have? It has 1. So this is going to be K1 plus. And if you're really careful looking at your periodic table, you can see up above the number 1, there's a teeny, teeny, tiny 1 plus. So when we look at sulfur, sulfur has 6 1, 2, 3, 4, 5, 6. Pretend those are lined up. The sulfur a metal or a nonmetal? It's not a metal. So that means it's going to gain. If it already has 6, how many open spots does it have? It has 2 open spots. So that means this is going to be S minus 2 because it gains 2. There's 2 open spots there. If I go fluorine, you're right, way too large. My B. Fluorine has 7. 1, 2, 3, 4, 5, 6, 7. Is fluorine a metal or not? It's not a metal. That means it's going to gain. How many open spots does it have? It has 1. So this is going to be F1 minus. And then the trick question of the day, thinking caps on, neon is Ne. Neon has how many? Neon has 8. So does neon want to gain or lose? This one's the trick question. If it already has 8, it doesn't want to do either. So it's not going to form an ion. This is just going to be neon 0. So I plan on going through these notes. If you were in the meet, you already got all this. If you didn't, this is what you missed today, but we're going to keep expanding upon this the next couple days as we conquer ionic bonding. Have a great day, everyone.